just by going by, just going by the speed of innovation that's happening in AI, it would be unwise to bet against anything in AI. So I think, at least in my years of experience, I haven't seen any other technology after the internet itself, which is benefiting from so much of collaborative work and almost like a network viral effect. Of course, there have been many such types of technologies along the way. But AI is the speed at which it is evolving and innovating is mind-boggling. So when we look at AI for 6G in a very sort of telescopic lens, we can think of the AI use cases as broken up into two broad categories. There's a centralized set of applications, which at this point of time, knowing what we know about AI, are somewhat obvious and a given. And every network equipment vendor and every network operator is already planning to utilize AI for a lot of these use cases. The key motivations for these, of course, are large volumes of data in the network. For example, a base station might have like 2000 KPIs, which is pegging every 5 minutes or 10 minutes, which is getting recorded every 5-10 minutes. And all of that data is now going, and with 6G, of course, with the densification of the network, you have a much larger multiple of the data that has to be processed. Secondly, the operation of these networks, also because of densification and because of the number of devices on the network and the wider bandwidth, etc. These are very large networks and highly complex, and getting even more so. These become operationally quite expensive to manage, and it requires, if not a complete AI solution, at least AI assistance to be able to handle these. And thirdly, amongst the central category of applications, there's the efficiency of network resources and network optimizations problems that are not new to 6G, but probably just get more and more enhanced in terms of what is required. The second bucket, as I see it, are basically the distributed applications. These are applications that get embedded in the RAN itself. And when I say embedded in the RAN, that includes the radio, as well as the base stations, the CU and DU. So one can think of even applications that are based in the CU as centralized, but I choose to kind of put them all in one bucket as distributed in the RAN. Couple of opportunities there, include hardware acceleration, mostly because of newer ways of parallel processing and vector processing and handling teraflops of operations in like a single GPU, for example. And of course, the integrated data which comes from the sensing that So coming to the central question, will AI find a central role in 6G? There are a few opportunities here. Maybe the couple of things will be like hardware acceleration in the RAN, which allows us to sort of make existing algorithms much better. There's semantic communication, which is being researched, which allows us to compress data inside the RAN significantly. But we also, it's a mixed bag. We also get a certain amount of challenges that come with it. The first one is that the RAN is extremely sensitive to the total cost of ownership. So before we increase the cost of each network element, it needs to be sort of well justified with the benefit that we're going to get with the additional functionality. The second thing is something completely new for AI and comes purely for AI, which is that today the RAN is well explainable. So if we find a problem, we know what happened, and looking at the data, we'll be able to explain which algorithm did what. But with AI, this becomes somewhat of a black box, and it may not be possible for us to understand why the AI model made a decision that it did. Finally, the AI model might also lead to unanticipated output when it's presented with an input that is not seen, and it might cause something unexpected in the RAN. Not a major crisis by itself, but it is something that we have to keep in mind.